Alright guys, we are going to work through our notes for graphing motions for ICP. We are going to do just a little bit of graphing. The problem is we need to get to a review on our algebra first before we get started. Okay, this is a different setup than I used to, so sorry if I don't quite go through at the pace I'd like. Something about the old program I used just doesn't work anymore. Okay, so what we have is when we're looking at slope. So if we go back to math class, and we think about math class, what is slope? And we're just going to say slope is, the letter M, and that is rise over run. As that when you look at anything, or any slopes, it's always going to be rise over run. So what we are going to do then is then look at, can we denote if something is a positive, negative, zero slope? We're not really too concerned about undefined, just because we really just don't use it this class. Okay, how do we know about positive slope? Well, if I draw a little stick person here, and we look at what direction are they looking, and they are looking up. So it's kind of a silly example to help remember what is a positive slope. If we put a little stick person on there and they're walking to the right, what direction would they have to be looking up? Is up. And so then optimistic people tend to look up, they tend to be positive, whereas pessimistic people tend to look down. All right, they're negative. All right, they're not really excited about anything. And then usually at some point, I usually talk about one of my students in class about how they have a zero slope. They're not excited to be there. They're just meh. And so they're just zero slope. They're not excited. They're not sad. They're just there. So where do we go from here? Okay. Well, if we talked about slopes already, now how does slope apply to what we have here? Now this is going to be a little bit of math magic, so we're gonna get there eventually. You got slope, which is rise over run. But if we look at this graph right here, what do we notice is this is a displacement versus time graph. So what can we do with this? Well, if we look at our rise, the variable on our y-axis here, let's go back to red. This variable on this y-axis here is displacement. So we have displacement. What about our variable along the run, or our x-axis? And that is time. What we just learned last week was that velocity is displacement over time. That's it. So the slope of a position versus time graph tells us velocity. So if we look in here, let's look at this example. We start off with a positive slope, and then we level off. And so this slope is then going to be 0. It's not going up, it's not going down, it's just there. So what can we do with this now? Well, we notice that, I'm going to draw a little picture of an image here. If we have this little dot, and it were to be following this line, after a while it would go to the right for 25 meters, and then it would stop. So what was the velocity of that dot? So velocity is displacement over time. This dot went up 25 meters, and it went over for 5 seconds. So 25 divided by 5, that's 5 meters per second. So even though we just found out that the velocity here is going to be positive, I'll erase this a little bit. Here we go. There we go. Even though we already found this velocity is going to be positive, positive what? Well, our rise, I'll just do it again, was 25 meters, and our run is 5 seconds. So 25 divided by 5 gives you 5 meters per second. What about this right here? Well, the slope is at 0 since this is a straight line. So the velocity here is just 0. Okay? So what I'm gonna do now is I'm gonna go to here, and I want you to calculate the velocity or the slope of this line at the 4 different spots. So I want you to legitimately try this on your own. We're gonna have velocity 1, velocity 2, velocity 3, and velocity 4. We'll call this velocity 1. Let's do this in red so we can see it. So we got velocity 1, velocity 2, velocity 3, and velocity 4. Okay, so go ahead and pause the video. Try this out on your own. Do I get the slopes or the velocities that I should be getting? Okay, hopefully pause the video and did it on your own. I want you to try this out. What do I notice is my slope or my rise of this first velocity right here? Well, I notice that the line goes up from 0 to 60, so this is going to be 60 meters. And then we went over, what's that going to be, 10 seconds? There we go, 10 seconds. 60 divided by 10, 6 meters per second. Our second velocity here, we notice that this slope is flat. It's straight across, which means it's going to be 0. So your velocity is 0. Up next, we have this downward slope. So we know it's going to be negative, but negative what? Okay, so here's the thing. You can take the slope of the whole line right here. Absolutely. However, I'm just going to take it from here to here. Since this is a straight line all the way through, any point we calculate slope, it's going to be the same. So for this first part right here, we go down 60 over 15. Because we started at 60, we went to the 0, which means this is down 60. So that's negative 60 meters. And then went over 15 seconds. So that'd be negative 4 meters per second. Okay? And then we got the last one here. What about this number 4? Number 4 is going to come out to be, well, we go up 40, so that's going to be positive 40 meters over 15 seconds. I believe this is going to be a irrational number, so I have to round it. So we're going to do 2.67 meters per second. Okay? If you didn't get those numbers, come talk to me. All right, come talk to me. I'd love to help you figure it out and walk you through it if these examples weren't helpful. Okay? Okay, so what we've done is we've looked at slope of a position versus time graph to find velocity, and that's kind of all we're going to be doing here, okay? We're going to skip past the change in speed in those examples for a little bit. We're going to save that off for later. Instead, we're just going to stay right here in this pocket. Okay, so other than looking for velocity from the graph, I want you to be able to convert in this lesson as well. Okay, so when we convert anything in the world ever, you need what's called a conversion factor, or a number to convert between two things. So if I take 1 dozen eggs, think 12 eggs. If I told you, I don't know, 4 quarters, $1. Any number that also compares to another number can be used as a conversion factor. So what we're going to do right here is these 3 are going to be our important ones right here. 1 kilometer, I would say this is absolutely have to be needed in your pocket for your homework and for doing problems in class. 1 meter is 100 centimeters. and 1 meter equals 1,000 millimeters. Okay, those three numbers you're absolutely going to be using when it comes to doing your conversions that you might not already know. We also use time, so like 60 seconds is a minute, 60 minutes is an hour. You're going to use those, but hopefully by this point you know those on your own. Okay. All right. How do we convert? So here's the very first thing you always want to do when you convert. You take your number and you just write it out. So we start off with 3 meters per hour. We want to go to centimeters per hour. Well, what do we do there? We want to go from meters per hour to centimeters per hour. Hopefully you can see that this hours down on bottom we're not going to touch. We actually want to keep the same. So the only thing I'm actually going to be doing then is taking these 3 meters and converting it to centimeters. So if we were to go off into algebra class and I'd do 7 over 3 times, let's do 6 over 7, hopefully you would know that these 7s could simplify or cancel out to 1. You could even simplify this to 2 over 1. So in the way that the opposites can cancel out as far as numbers go, same thing can happen with units. So if I want this meters to cancel, we're going to put meters down on bottom. And what are we going to? We're going to centimeters. So if I go from meters to centimeters, what do? We look at our conversion factor. So that number we wrote down just a little bit a while ago, 1 meter equals 100 centimeters. 1 meter equals 100 centimeters. We put the number where it goes. 1 meter, 100 centimeters. And then let's just calculate, it's just math from there. Meters cancel out because they're opposite of each other. And I'm left with centimeters over hours. And what's 3 times 100? 300. So 300 centimeters per hour. Okay? So there's our answer for that one. What we're going to do is we're going to do the second one. I'm not going to wait for you because I'm actually going to do this. This is not this example like this first one. It's a little bit more difficult. So we're still going to do it together. You're welcome to try it on, I guess, if you want to pause the video, but I'm just going to keep going on. 1516 meters per minute. We want to convert that to kilometers per hour. So the problem is that if we want to get this to kilometers per hour, we have to convert both the kilometers and the hours. We have to convert both units here, which is why I've drawn a little bit more space than I usually do. Okay? So let's think about first. If I want this meters to cancel, it's going to go on bottom. Meters to kilometers. Okay? Now we just wrote down that number down earlier, that 1 kilometer is 1,000 meters. So 1 kilometer is 1,000 meters. Okay, so we got meters to cancel out. Now I'm left with kilometers per minute. I need to be in kilometers per hour. So if minutes on bottom, we're going to put minutes on top because we want it to cancel. And hours is going to go on bottom. How many minutes are in 1 hour? Well, in 1 hour you have 60 minutes. Okay? Minutes cancel out. I'm now left with kilometers per hour. We've got our unit correct, but I'm going to run out of space here. I run over my calculator and do the calculation. What do we do? I'll do 1516 divided by 1,000 times 60. So I get 90.96 kilometers per hour. Okay? This is a little tricky. Okay? I actually don't think you're going to be doing these examples in your homework. I just think we did it as a class all of your homework, you have to do one-step conversions. So this first one up here, okay? You're welcome to try this bottom one out on your own, okay? I'm going to go ahead and just get an answer for you to see if you did it right. You should get divided by 1,000, divided by 1,000 times 16, 25.92. Okay. You're welcome to try that on your own. If you can't figure out how to get 25.92, welcome to come talk to me, and I'd love to help you figure it out. You guys are awesome. That's it we're going to be doing this week. We're looking at graphing, how to calculate velocity from the graph, and how to do a little bit of conversion. All right, stay classy, guys, and I'll see you in class soon.